Dear students, welcome to this video lecture session. I am K. Karthik Vendan, Assistant Professor, Department of Mathematics, Government College of Engineering, Srirangam, Trichy. In this video, we are going to discuss the definition of a set and its representations with real-time examples. Okay. Before going mathematically, set is nothing but purely a collection. That's it. See, collect some numbers less than 10. Collect the alphabets. Collect the Hindi alphabets. Collect the English alphabets. Right? Like that, we can go on collecting infinite collections. We can do it, right? No doubt in that. See, there is a very important difference between verbal meaning and a mathematical meaning for a set. See, verbal meaning is just a collection, right? Okay. Mathematically, that collection should be well defined. Each and everything must be defined very clearly. That is what very important. For example, if I am saying collect the alphabets, what alphabets you will be collecting? There are many languages throughout the world, right? So that won't be a set. Mathematically, that won't be a set. If I am saying set of all alphabets, it's not a set. Why? Because you can't write specific alphabets. If I am saying set of all alphabets, means there are many alphabets, English alphabets, Tamil, Telugu, Malayalam, etc. Throughout the world we are having many languages. So that collection must be well defined. For example, set of all English alphabets and Tamil alphabets. Now this is a set. Now you can write the set, right? This is what I am just telling you, the meaning for well defined. Okay. Now we will represent the set as capital letters. Okay. And the elements inside it as small letters. For example, see, capital A equal to A, B, C. Capital B equals to 1, 2, 3, 4, 5, and capital C equals to A, E, I, O, U. See, the set is denoted by capital letters, and this is what the set, and the elements will be represented by small letters in general. It may be numbers also, no issues, but that entire collection should be within the flower bracket and it should be given a capital letter. That is what very important. This is how we should notate a set and its elements. Okay. See, we shall see some real-time examples and non-examples now, right? Take the first collection. I am just taking collection of students. Okay. See, is this mathematically a set? Think clearly. What were the students you will be collecting? That is what I am asking you. There are pre-KG students, LKG students, UKG students, college going persons are also named as students. So it is not precise, right? Everything, whatever they are asking you to collect, that must be crisp and clear. Okay? That must be very clear in what they are mentioning. So it is not a set, right? Okay. Now the second example, collection of second year ECE students. You can name anything. Second year ECE students means at present there will be many easy students, right? Compare the second example and third example. Collection of second year students studying in Anna University. Studying means at present they should study. That is what very, very important. At present. It's a present tense. Studying means present tense, right? So it will be a set and this won't be a set. Okay. Now, collection of second year easy students studied at Anna University. How will you collect that? Is there any batch mentioned? Not, right? See, for example, see the difference between fourth and fifth one. Collection of second year students studied at Anna University during the academic year 2019 to 2020. See, for example, in the previous academic year. Now the current academic year is 2020 and 2021. In the previous academic year, the students who are studied in Anna University, who are second year easy students, we can collect it easily. Around 500 colleges will be there. You can collect it easily. See, if I am asking you to collect this data, for example, fourth data, if I am asking you to collect, will you collect? Is it possible? Not at all possible. So here the mentioning is not clear, right? It is not at all clear, whereas in the fifth example it is clear. See, what the point I am trying to conclude you is, think yourself there practically. You have been asked to collect. Okay. If it is well defined only, you will be giving out the data whatever they are asking for, right? If there is a chance for questioning, that is not a set mathematically. That is what very, very simple, right? See, next we shall see the representation of a set. Okay. We are naming in two representations. One is roster representation and the another one is set builder representation. Okay. See, roster representation means it's very, very clear. They won't give you any task. They will list out the elements like this. Okay. This is what the roster representation is. They will list out what were the elements inside the set. Okay. For example, A equal to 1, 2, 3, 4, 5 and capital A equal to A, E, I, O, U and B equal to 2, 3, 5, 7. Like that they used to give you in a explicit manner. That is what called as roster representation. Whereas in set builder notation, that is what very, very important. See, they used to give like this. See, they used to give like this. For example, the set A. I am just defining set A. Equals to, I will read like this, set of all x, set of all elements such that x satisfies some property P. See, that is what clearly mentioned here, right? Set of all x such that x has a property P. See, it is not at all possible to give everything in a roster form. Okay, clearly mind it. It is not at all possible. Whereas the set builder notation is possible. But you have to shoot out what were the elements and you have to understand what the set is. Right? See, for example, I am defining like this. Set A equals to set of all elements x such that 1 less than x less than 10. If I am defining a set like this, is it possible for you to write the elements of A? See, blindly speaking, many people will be writing the elements like this. For example, 1 less than x less than 10 means x must be greater than 1 and it must be less than 10. So many people will be writing like this: 2, 3, 4, 5, 6, 7, 8, 9. You people must check out initially where this x belongs to. Here they didn't mention x belongs to natural numbers, or x belongs to integer, or x belongs to real number. They didn't mention anything. If they are mentioning it only, then it is right. If they are not mentioning, you could not proceed to the next step at all. See, this is correct for x belongs to n and x belongs to z. X belongs to n means natural numbers and x belongs to z means integers. If I am giving these two options, this is correct. Whatever you have written is correct, but this is not the case in this real numbers. It will be a infinite set. Okay, it will be a infinite set in case if I am representing x belongs to R. Okay, see, x belongs to R means real numbers. Could you say what is the number next to 1 in real numbers? If take a number line, you people know the number lines, right? Minus infinity, 0 and infinity. This is positive region and this is negative region, and they are telling you 1 to 10. Could you people say what is the number next to 1 in the number line? No one can say, right? If I am saying 1.1, you people can say 1.01. Another one may tell 1.001. Another one may tell 1.0001. And this argument goes on. So you could not shoot out the element next to 1 in case if the taken set is a real number. That is, if I am telling you x belongs to R, you cannot perfectly write all the elements, but the set is very well defined. That set is this interval. In this case, if I am telling x belongs to R means x means elements. The elements belongs to real numbers, and at the same time that element must satisfy in this limit. That is, that element must be greater than 1 and it must be less than 10. That is what they are meaning. See, if the element belongs to natural number, what will be the case? What is the natural number next to 1? You people can say it is 2, 3, 4, 5, 6, 7, 8, 9. You should stop there, right? Why I am stopping there? They are telling less than 10. Okay. If I am marking less than or equal to 10 means I will be writing one more element. That's it. And if I am marking here less than or equal to means I will be adding another element 1. That is what. Okay. Very simple. Right. Likewise, I am just giving 3 examples. One in roster notation, and for the same thing, I am giving out the set builder notations. See, for example, if the roster notation is a equals to 1, 2, 3, 4, 5. For this, I can represent a set builder notation like this. I am representing in 5 ways. There are another ways also. See, for example, see, I am just clearly mentioning x belongs to natural numbers. Natural number starts from 1, right? And this is the property here. What is the property? X less than or equal to 5. X less than or equal to 5 means natural numbers starts from 1. So only option is I will start from 1, 2, 3, 4, 5. I should stop at 5. Why? Because here the condition is less than or equal to 5 means I should stop at 5. Why I am starting at 1? Since the natural number starts at 1. See, the same set can be represented like this also. X belongs to Z. See, if I am writing A equals to as like this, X belongs to Z such that X less than or equal to 5. What will be this set? Could you tell me? What will be this set? Z means integers. Integers means negative also included. Okay, negative also included and 0 and all the positive numbers. So I'll be writing 5, 4, 3, 2, 1, 0, minus 1, minus 2, etc. This is an infinite set. This will be the case. Okay. So that is why I am mentioning the lower bound here. Okay. 1 less than or equal to x less than or equal to 5. If I am mentioning that element belongs to integer, I am just more precise on my condition. That is what. In set builder notation, the condition is very, very important. You should clearly extract what is the condition here. Here they used to tell where that element belongs to. Okay. Very important is in set builder notation, here they will tell you where that element belongs to. And in the second one, they will tell you the property of that element. That is what the idea of set builder notation. I am just repeating you once again. See, here they will tell you where that element belongs to. That element belongs to English alphabet. And the property is another filtration. Okay. What is the filter? That must be a vowel. So the elements will be A, E, I, O, U. Right. Now see, here they used to represent where the element belongs to. That element belongs to natural numbers in the first one. Second one is condition. That element must satisfy this condition. If I am writing natural number means all the natural numbers I will be writing 1, 2, 3, 4, 5, 6, 7, 8, 9 like that. It will go on. But the condition is among the natural numbers you should collect the prime numbers. Okay. That is what important. So I am writing the prime numbers here. Okay. Thank you, students.